Hey everyone, and welcome back. Today, we're diving into a common car issue that can leave you scratching your head. Those pesky P0171 and P0174 error codes. If your check engine light has popped on and you're seeing these codes, it means your engine's air-fuel mixture is running too lean on both bank 1 and bank 2. Essentially, your engine is getting too much air or not enough fuel, which can lead to poor performance, reduced fuel efficiency, and even potential engine damage if left unaddressed. Now, a dirty mass airflow sensor is a frequent culprit behind these lean codes. This sensor is crucial because it measures the amount of air entering your engine, and the engine's computer uses that information to calculate how much fuel to inject. When the MAF sensor gets dirty, it can't accurately measure the airflow, leading to that lean condition. But what if you're trying to clean your MAF sensor and run into a different kind of frustration, a stripped screw? It happens to the best of us, and it can feel like a roadblock, but don't worry. In this video, we're going to walk through how to safely clean your MAF sensor and how to tackle that stubborn stripped screw without causing further damage. I'm really excited to share these tips with you, and I hope they help you get your car running smoothly again. If you find this tutorial helpful, please consider giving it a like and subscribing to my channel. Today, I'm working on a 2010 Toyota Tundra with a 4.6 LV8, but the MAF sensor on most vehicles is usually located somewhere between the air filter box and the throttle body. I'm using a 10mm socket to loosen the hose clamp so I can remove the top of the air cleaner. Normally, you can remove the MAF sensor without taking the air cleaner apart, but as I mentioned earlier, one of my mounting screws is stripped. It'll be much easier to deal with that on my workbench than while leaning over the engine bay. The first screw comes out without any problems, but we'll head over to my workbench to remove the stripped one. I'll be using a screw extractor kit that I picked up on Amazon. It's a simple tool that's worth having around, because it can save you a lot of frustration when you run into stripped screws like this. The extractor has two ends. This end is used to drill into the damaged screw head, and once that's done, you flip it around and use the other end to bite into the screw and back it out. Both ends of the extractor are designed to be used in reverse, so before you start, make sure your drill is set to reverse. Start with the drilling end of the bit. The goal here is to remove the damaged Phillips slots and create a clean surface for the extractor to grab. You don't need to drill very deep, just enough to give the extractor a solid bite while leaving plenty of the screw intact. These kits come with several extractor sizes, so be sure to choose the one that matches your screw. If the bit is too small, it may not get a good grip. If it's too large, you could remove too much material. Once you've drilled the screw, flip the bit around and use the extractor end. Keep your drill in reverse, apply steady downward pressure, and go slowly. As the extractor bites into the screw, it should begin backing it out. Don't force it or run the drill at high speed. Slow and steady usually works best. If the screw doesn't come out on the first try, don't panic. Sometimes it takes another pass with the drilling end to give the extractor a little more to grab onto. After a second attempt, the screw backed right out. Now that the mass airflow sensor is out, we can start cleaning it. I'll be using CRC Mass Airflow Sensor Cleaner, which is specifically designed for this job. It's important to use a cleaner that's made for MAF sensors. Other products like brake cleaner, carburetor cleaner, throttle body cleaner, or even electrical contact cleaner can leave residue or damage the delicate sensing elements inside the sensor. When you're spraying the sensor, focus on the small sensing wires and the air passage where dirt and oil can build up. Give those areas several light sprays until any contamination is washed away. Avoid spraying the electrical connector where the wiring harness plugs in. That area doesn't affect the sensor reading and doesn't need to be cleaned for this repair. Also, don't touch the sensing wires with your fingers, a brush, or a rag. They're extremely delicate and can be damaged very easily. Once you're finished spraying, just let the sensor air dry completely before reinstalling it. While I'm waiting for the MAF sensor to dry, I'm going to clean up the air cleaner housing. Since everything is already apart, this is a great opportunity to get rid of years of dirt, grease, and grime before putting it all back together. I'm just using some isopropyl alcohol on a shop towel to clean the surface. It evaporates quickly, doesn't leave a residue, and does a great job removing grease and built-up dirt. Once it's clean, I'm going to apply Chemical Guy's VRP. VRP stands for vinyl, rubber, and plastic, and it's one of my favorite products for restoring faded plastic and giving it a clean, factory-looking finish. It doesn't leave behind that greasy, overly shiny look that some dressings do. I use this on just about everything. Engine bay plastics, exterior trim, rubber seals, and even interior plastics. It also works great around the house. In fact, I used it to restore the faded plastic shutters on my home, and they looked almost new again. It's one of those products that keeps proving its value because I find more and more uses for it. If you're interested in any of the products I used in today's video, the CRC MAF sensor cleaner, the screw extractor kit, the Chemical Guys VRP, or any of the tools, I have links to everything down in the description. Those are Amazon affiliate links, which means if you purchase something through one of those links, I may earn a small commission. It doesn't cost you a penny extra, but it does help support the channel and allows me to keep creating tutorials like this. A lot of channels will recommend products just because they're popular or because they're sponsored. That's not how I want to do things here. I'm just a dad who enjoys working on cars, fixing things around the house, and sharing what I've learned so maybe someone else can save a little time, money, and frustration. That's really what Instructions Optional is all about. The name comes from the fact that most of us would rather start turning wrenches than read a manual, but while instructions might be optional, research is not. If I recommend a product, it's because I've personally used it and trust it, or because I've spent the time researching it before I ever recommend it. If it's in one of my videos, it's something I'd use on my own vehicle or in my own home. Now let's get the MAF sensor back in place and reinstall the air cleaner housing. Then we'll connect my VPAC OBD2 scanner and the car scanner app to see if the trouble codes have cleared. And, more importantly, check our fuel trim values to see if cleaning the sensor made a difference. Now let's take a look at the diagnostic process and see why I decided to clean the MAF sensor first. After the check engine light came on, I pulled the diagnostic trouble codes and reviewed the freeze frame data. Then I used the car scanner app with my VPAC Bluetooth OBD2 scanner to monitor the engine's live data. In this first screenshot, the truck is idling at 0 miles per hour. Notice the short-term and long-term fuel trims on both banks. They're all significantly positive, with the long-term trims close to 30%. That tells us the engine computer is adding a lot more fuel than expected because it believes the engine is running lean. Now look at the second screenshot while I'm cruising at about 53 miles per hour. The short-term fuel trims have dropped back to around 0, but the long-term trims are still elevated. At idle, the engine is pulling high vacuum, so even a small vacuum leak can have a big impact on the air-fuel mixture. As engine speed increases and more air flows through the engine, that same leak becomes a much smaller percentage of the total airflow, so the short-term fuel trims improve. A dirty or underreporting MAF sensor can produce very similar symptoms because it's telling the engine computer that less air is entering the engine than actually is. The computer injects too little fuel, the oxygen sensors detect a lean condition, and the fuel trims climb as the computer tries to compensate. At this point, there were several possibilities. It could have been a vacuum leak, a dirty or failing MAF sensor, low fuel pressure, or even an exhaust leak ahead of the oxygen sensors. Cleaning the MAF sensor was the quickest, easiest, and least expensive place to start. It only took a few minutes and cost a fraction of what replacing parts would have cost. Now take a look at these final screenshots after cleaning the sensor. Both the short-term and long-term fuel trims are back within a normal range and the lean condition is gone. The check engine light has stayed off and the only code remaining is a previously stored code unrelated to this repair. That's exactly the result we were hoping for. If this video helped you diagnose or fix your own vehicle, I'd really appreciate it if you'd give it a thumbs up. If you have any questions, drop them in the comments below. I'll do my best to help. Thanks for watching and remember, instructions might be optional, but research is not.